Hello, this is the second video in a series of probably 3 videos involving complex numbers, and this video focuses on how they might come up in solving equations. The previous video was just looking at the arithmetic with complex numbers. First question is just a memory question. When solving a quadratic equation that has the format ax squared plus bx plus c equals 0, a, b, and c are the coefficients, then you can solve for x by saying that there's the formula that you can plug the a, b, and c into. That formula is the opposite of b plus or minus the square root of b squared minus 4ac. And then that entire thing is divided by twice a. Now, that's one technique to solve quadratic equations. Another one is completing the square. And so, completing a square is based off of the desire to have a perfect square. For example, x plus 5 quantity squared. When you multiply that out, you get x squared plus 10x plus 25. Completing a square is when you have two of the terms in that trinomial and you want to add in the constant term so that it is a perfect square. What you do is you exploit the relationship between the number that's in the square, the number that's the coefficient on x, and the constant term. The relationship is that the number that's in the square is half of the coefficient on x. And then the number that is the constant is the square of what you just found. And so we're going to use that technique on this first question, and then we'll use the quadratic formula on the next question. The key, though, is that it must be set equal to 0. And so we'll take and move over the terms that are on the right-hand side. We're going to subtract over 12 and add over 4x. Let me conveniently put the minus 12 underneath the 60 and the plus 4x underneath the 12x, leaving us with 0. And then the quadratic is 2x squared plus 16x minus 48. If you happen to recognize that all the coefficients share a common factor, it'd be very beneficial for you to factor that out. And so we're going to factor out a 2, leaving us with x squared plus 8x minus 24. It's going to be equal to 0. And basically we drop the 2. What happens is we divide both sides by 2. And 0 divided by 2 is 0. So here's what we have. X squared plus 8x minus 24 equals to 0. I'm going to go with completing the square here, where I am going to add something to both sides of the equation. Balance it out. That something is going to be critical to giving me a perfect square. I'm going to exploit that relationship and end up with a perfect square. Okay, so let me add a space And then whatever I put inside that box, I'm going to put also on the other side of the equation. This is going to end up as a perfect square. Okay. And so, what's the relationship? What's inside with the square is half the coefficient on x. So you put a 4 there. Then the number that you're adding to both sides is the square of that. So 16 gets added to both sides. Now, you still have that minus 24 on the left-hand side, and now 0 plus 16 on the right-hand side is a 16. The purpose of completing the square is to be able to solve the equation for x. Your job is to isolate the squared term by itself. That 24, get that out of there. Add it to both sides. And what you'll have, 24 plus the 16, so you have 40. You have x plus 4 quantity squared equals 240. Now, almost done. Our job, take the square root of both sides. Okay, the square root of a perfect square will equal what's underneath the thing that's being squared, and then square root, these are opposite operations. They cancel each other out. And so I'll have just x plus 4 on the left-hand side. On the right-hand side, I have to take the square root of 40, but there is a need to remember that it is plus or minus. When you square that, you'll get 40, whether it's negative the root of 40 or positive the root of 40. Okay, great. Now, we're done when we can just get x by itself. Our job finally is to take away 4. And officially, we're going to write the answer as x equals negative 4 plus or minus root 40. Imaginary numbers didn't come up. We didn't have any complex answers, but they could come up had there been a negative underneath that square root. So that would be the answer to this number 9 with the technique completing the square. Let's look to number 10 and use the technique of the quadratic formula. 7x squared plus x minus 10 equals x squared plus 7x minus 1. Okay, great. Don't start the quadratic formula without setting it equal to 0. So these terms need to be moved over to the other side by doing the opposite of what they are. We're going to take away an x squared. We're going to take away a 7x. And we're going to add on a 1. Conveniently put them underneath the guy that they're going to be used to be added or subtracted from. So you can vertically add 7x squared minus x squared is 6x squared. 1x minus 7x is minus 6x. Negative 10 plus 1 is a negative 9. It's equal to 0. If you notice that all the coefficients share a common factor, please factor out because it makes all the numbers in the problem smaller. We take a 3 out and we're left with 2x squared minus 2x minus 3. What happens with that 3, you kind of just drop it. What happens is we divide both sides by 3, and now it's gone. And we have 2x squared minus 2x minus 3 is equal to 0. If we're going to use the quadratic formula, it's our job to identify the variables that we're plugging in. A is the coefficient on x squared, B is the coefficient on x, C is the constant term. Make sure you're very careful with the negatives. Now, our job to plug into the formula that x should be the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, great. I like to figure out what b squared minus 4ac is first. It makes it the write up a little neater. B squared minus 4ac would be equal to a negative 2 gets squared, and then you take away 4 times 2 times a negative 3. And so that is a 4, and then these two negatives is going to end up giving you a plus. And 8 times 3, that's a 24. So you get 28. That's what goes underneath the square root. So here we are with the opposite of a b plus or minus the square root of 28 all over a 4, 2 times 2. That's what x should be equal to. That is 2 plus or minus. When it comes to the square root of 28, we define a perfect square that goes into it. 4 does. So we're rewriting 28 as 4 times 7 with a goal in mind of breaking it into 2. Since it's multiplication, we can do that. And we end up with 2 rad 7. 2 times the square root of 7 is the simplified version of the square root of 28. That whole thing is divided by 4. Last step is that the 4 is underneath both of them. And so we have 2 over 4, break it up, plus or minus 2 over 4 root 7, or 2 root 7 over 4, or a final answer of 1/2 plus or minus 1/2 of the square root of 7. No imaginary numbers there either. All right, let's end this video, and then we'll go to the last couple questions involving imaginary numbers, I think, with the quadratic.